Example 2, integration by substitution. It says find the integral of dx over the square root of e to the 2x minus 1. Again, we're going to look at the given problem and try to match it to one of the structures that are given in this theorem 5.17. So I'm looking at it, I see a square root sign, I see e to the 2x minus 1, and I'm thinking maybe it's this one. But let's see. Let's take a look. My inclination here is to allow, let's let u equal e to the 2x. And when we do that, this will be rewritten as the integral of dx over the square root of, actually, not e to the 2x, just e to the x. And that's going to allow this to be written as u quantity squared minus 1 squared. So let's see. It looks like possibly it could be this one, but the one thing that's holding us back here is that notice that it's a squared, so the constant is first, and then minus the u squared. So maybe it's not that one. This one over here, this one has no radical sign. And then this one over here, I mean, these are, the u and the a are in the right order. It does have the minus sign, it has the square root, but then we have this u here. So I'm not quite sure which one to use yet. So let's go a little further. Let's take the derivative, and we know e to the x is our favorite because it's its own derivative. So I have this, and something kind of cool is happening here. Now remember, my job is to rewrite this in terms of u. So this dx, I need to replace that. So I have a dx here, and I see that the e to the x is extra. I don't need that. So I'm going to divide both sides by it. And that might be kind of a scary thing to do, because then you look over here and you have this 1 over e to the x du equaling dx. And I thought we were supposed to get the u's by themselves. But there's something kind of cool that's going to happen here. So watch. I'm going to replace dx with 1 over e to the x du. And I'm going to do it in the following way. I'm going to write 1 over e to the x. And then I'll put the dx, sorry, not dx, du. And then I have my u squared minus 1 squared. And here's the thing. Remember that we've already said that u is equal to e to the x. So I can replace this here by a u, which would turn it into this. Well, that seems to look a lot like arcsecant. So it looks like we have what we want. So now let's actually write this answer out. One more thing. We've identified our a as being 1, our u as being e to the x. So when I write my answer, it's 1 over a, which is 1 over 1, times arcsecant of the absolute value of u, which is e to the x, over a, which is 1, plus c. Well, 1 over 1 is just 1, so I'm going to write arcsecant, and then absolute value of e to the x over 1 is just absolute value of e to the x. And there is our answer.